Hey guys, welcome to my garage. This is like a personal interview, me to you, giving some grad school advice. So first thing I want to talk about is how to choose a professor. So if you know you want to go to graduate school, the next decision is which graduate school do I go to? And that kind of comes down to what you're interested in studying. So the best thing to do that I found, and my experience is in physics, your experience may be different, chemistry or biology or engineering, but it's going to be pretty similar. So I pick up journals that are relevant to the field I'm in, like Applied Physics Letters or something like that, and I'll read through the abstracts of the journals. And doing that, you'll find articles that are interesting to you, or you'll kind of see what the state of the art is. Find the professors that have written those, find their colleagues, and start looking at universities. That's one way to start. So starting from places that are interesting to you. The other way, of course, is just to look up a list of top universities in the country and choose places you might want to live. And somewhere in the middle, you'll find some schools that you want to go to. But I would caution you, before you choose a school that you're going to go to, make sure that they have at least 4 professors that you wouldn't mind working with. And here's the reason. One of them's going to retire, one of them's going to move, one of them's going to run out of money, and they won't be able to hire you to do research, and one of them is going to be a total jerk. So make sure you've got a university with at least 4 professors you didn't mind working with. That's my first rule of 4. The second thing that you want to do is be aware that there are different types of research groups. And I'm going to characterize these as the hammer, the nail, theory, and the shark. So let's start with the hammer. The typical hammer research group is a group that has a big tool, like a high magnetic field laboratory, or they've got a big laser, or they've got some press that they use to crush materials, or whatever it is. Or they can do high-speed, femtosecond laser stuff, or whatever. So they basically have an instrument that they've spent a lot of money to build and a lot of expertise in that area, and that's their hammer. And they're going to take that instrument, that tool, and they're going to study everything they can possibly find to study with that tool. That's a hammer group. Everything to them is a nail, and they're just going to smash that hammer on anything. And that's a hammer group. So in a hammer group, what do? You get a lot of experience building tools, you get a lot of experience analyzing data, and a lot of times you'll be in a collaboration with other people who are providing samples or who basically want you to take data for them. So you get to have a lot of interactions that way. So I came out of a hammer group for UCSB. We had a free electron laser, which was an electron accelerator facility. So it was a lot of fun. I got a lot of hands-on skills. It led me to a career in product development. That was fun. The next group you want to have is the nail group. The nail group has some particular thing that they study. Just one thing, right? A nail or a screw or whatever. And they'll study that with every tool they can find. They'll hit that nail with a hammer and a screwdriver and a wrench. And so let's say I study DNA, or I study non-equilibrium statistical mechanics of boiling liquids or something like that. They'll have some medium that they're studying, and they'll study it with every possible thing. A lot of the nail groups tend to have some specialized fabrication capability. Like I can make special samples, like with an MBE, a molecular beam epitaxy machine, or they have some special chemistry synthetic experience or something like that. And then they'll go out to other groups that have specialized characterization equipment and get it analyzed. So that's the nail group. Nail group, you're going to get a lot of hands-on skills in materials preparation, materials characterization, and things like that. The third group we get is the theory group. In the theory groups, you tend to get the dregs of the funding. So you'll split your time between teaching classes and doing math. The nice thing is that you don't have to touch anything. You don't have to design any experiments or anything like that. You basically just analyze data, read papers. You'll have to do about twice as much schoolwork as the others will. You'll typically 4 years instead of 2 of grad work to get a PhD in the classroom. And basically, so that's your theory group. A lot of times you'll have some specialized expertise in a particular area of theory, computation, but you'll come out, working on Linux machines and possibly looking at careers in algorithms development or things that require a lot of computational skills. So definitely build your programming expertise if you're coming out of a theory group. The last group, and then one of the most interesting, is what I call the sharks. Now, everyone knows a shark smells blood in the water. And a shark is a professor who tends to be very renowned in their field, gets high levels of funding from places like DARPA. And the sharks basically they're always giving invited talks at conferences and things like that. There's a couple of key things about a shark group. One is that the professors are willing to jump fields very quickly. When they see that something big is happening, they will very quickly jump fields and then move themselves to the top of the food chain in that field, thus becoming a shark in that field. These groups tend to have very cohesive teams, and with the funding that they have, they're usually able to bring in good postdocs. And so they have a postdoc, a grad student, and an undergrad, sometimes even an assistant professor at the top of that. But the postdocs are writing the papers, and doing a lot of the theory. The grad students are taking the data and the undergrads are in the shop building the equipment. And that team can just run very quickly and very efficiently and get a lot of research done. So shark groups are very dangerous. They'll tend to be very driven, and you'll spend a lot of time in the laboratory in a shark group, but your professor will have big funding and he'll have a lot of connections. So shark groups may pull theory groups, hammer groups, nail groups into a consortium and go get funding, but yeah, the main PI, the principal investigator, is going to be the shark. So when you've decided what kind of group you want to work for, you got to make sure that you're not doing the wrong things. There's 4 questions I want you to ask: who, where, how, and what. So who are the people who graduated from this research group, right? And where are they now, right? Are they all professors? Have they gone on to industry and been successful? Are they working for their mother, selling flowers? Who? Ask who the people that have recently graduated are and what they're doing, okay? Where do they publish? What journals have this group published in the last 3 years? Is it Science and Nature, Photonics Letters, or does it tend to be like Physica Acta C or some like no-name journal, okay? That tells you how well respected they are in the field and how cutting edge the research is. Another one is how. How much money do they have? How do they get their funding? Are their funding sources consistent? Are they erratic? Are they going to run out in the next 2 years? How much money do they have? That's a good thing to ask. If you get to a group with super high funding, you might not develop real hands-on skills fixing stuff. That's a flip-flop, but you'll also get some great papers. So it's a trade-off there. Make sure you do work for some poor groups in your career and some rich groups. It'll give you really good experience both ways. And then what? What should I know about this group that I wouldn't know just by looking at your website? Or maybe moving into a new field or something like that. So definitely, and who are you going to ask these questions to? Not the professor, I'll tell you that. He's way too busy. You can't even get a hold of your own professor, let alone somebody else's. So the thing to do is just contact our grad students, send them an email, look up their phone number on their team website, whatever you can do, find a grad student, they'll talk your ear off. They love to give advice, and the grad students tend to like to talk about what they're doing, so you can ask them a lot about the research and their own stories, and they'll basically open kimono, they'll tell you anything you want to know. So just talk to the grad students that are already working in the group. It's a great thing to do. Grad school will teach you a lot of things, but probably not what you think you are going to get when you go into graduate school. You'll enjoy it. You probably get paid a stipend if you're in one of the hard sciences and a lot of the engineering classes. Most of the schools worth going to will pay you to go there. And so don't make money a big issue. Definitely pick a school and visit it before you decide to go there. I visited Stony Brook in New York, and I didn't really like it. I visited Stanford. It was okay, but the professors were pretty standoffish, not really interested in me. Got to Santa Barbara, and all the professors were very interested in me, very interested in having me in the research groups, and I felt very welcomed that I would be enabled there. So that felt like a good match for me, and who doesn't want to live on the beach, right? So that was pretty cool. So I encourage you guys, if you have any questions, email me, laserdad@gmail.com. Good to go. If you're in physics, definitely work in the help lab at your university with the semester right before you take the physics GRE, and you'll do really well. And good luck.